Hi everyone, my name is Shubhajit Shah. Welcome to our YouTube channel Helm of Science. So today is my first PYQ session of organic chemistry. See, in my video I will be discuss about the carbonyl chemistry. This carbonyl chemistry is very much weightage. It contains a very much weightage and it's a very important in terms of any competitive exam. It may be NEET, AIMS, JEE Advanced, West Bengal Joint, any competitive exam. In organic chemistry it will carry a lot of weightage. So today I will be discuss 4 to 5%. Maybe if we allow to we have time, then we will discuss 5 question. Either we will end with 4 question, but I can assure you this 4 question will help to solve other 20 questions of any competitive exam. They are much different from each other. The question is all are different from each other. There is not one type of question. So take note down properly the question and write it down by mechanism and understand how the mechanism will follow up the reaction. So what is my first question? So let's start. My first question is that there is contained a cyclic ester, that means a lactone with an 5-member cyclopentadiene ring having a acidic containing group. They will provide us a dival H. So we will start the reaction. So what is the reactant? Reactant is look like this is ester. Reactant is look like this, and they will provide us dival H. Now what is a dival H? What is dival H? Dival H is a specific reaction or specific reagent for preparation of aldehyde specifically. This is a specific reagent for the exclusive preparation of aldehyde. So this acid group will convert to aldehyde, and this cyclic group is also convert to aldehyde. No, so this COH to aldehyde is very simple, but the mechanism of this cyclolactone to aldehyde, we have to consider the mechanism. So what is the mechanism? It is a mechanism. I am starting the mechanism. Fine. This is our reactant. This is an acid. So dival H plus look like isobutyl group, 2 isobutyl group, diisobutyl aluminum hydride. Okay. So firstly, this oxygen of ester group has non-bonding electron. First, the non-bonding electron will coordinate with this aluminum. So how this will, if we will dival, then CCO is converted into CHO. That is simple, but in this case this is a trick. So fine. This is coordinate look like that, and aluminum, we know that aluminum has a vacant orbital. Fine. Now this oxygen will donate its non-bonding electron. So by the using of non-bonding electron, oxygen has positive charge on it. But we know that oxygen is an electronegative atom, and oxygen do not have this positive charge. It will try to neutralize. So how will it neutralize? This hydrogen of this dival H will go to this carbon of carbonyl group, and it will look away this one. So by this way, the pi bond of this C double bond group is dragged by this positive charge oxygen atom. So what is now our intermediate? Our intermediate look like this one, and this hydrogen will go to this carbon. So now how aldehyde will appear? This OL bond will break like this one, and this CO bond will break like this. So if this CO bond will break, then what happens? There as alcohol will generate. This is OH and this bond will break. So in this case there is a one CH2 group and this aldehyde. So this is our final product, that is option C. Fine, I am checking again the option, just a second. Sorry, this is option D. This is not C, this is option D. In this case C and D is product is look like same. In case of C, they will not convert COH to CHO. Fine, but in this dival H plus convert ester, acid, cyanide, everything to an aldehyde. So this is actually a ring opening reaction of lactone using dival H plus. So there is a two functionalities there, that is acid and that is lactone, that is a lactone, that means cyclic ester. By using of dival H, diisobutyl aluminum hydride, the non-bonding electron first attack to aluminum, coordinate with aluminum, then this hydrogen will transfer to in this carbon and we will get this intermediate, and after this breaking of bond and preparation of aldehyde, we get an alcohol. So this is our final product, and this is a very important. This is the question of JEE Main 2017. This is a very important question. Ring opening reaction and ring closing reaction is a very important and very tricky. So this is our first question. Now I will going to our next question. Now my second problem is also came at JEE 2017. The question is based on a conversion. This conversion involved in our reagent it containing a cyclic group, cyclohexane group, and containing an ketone and also an aldehyde. They will provide some reagent, like tolerance reagent. Fine. Then they will provide some reagent, and the question I will show you the question. It will clear that which types of reagent they will provide, and they will provide a system, the product containing OH group. Fine. So I will start to solve the problem. So this is our next problem or second problem. So in this case, what is we can observe? We observe this double bond convert into a, just a second. Sorry, this is an actual problem. Okay, fine. I am increasing the one carbon in this side. So very carefully. This is a carbonyl, ketocarbonyl, that means ketone. This is an aldehyde. This aldehyde convert to having two CH3 group and one OH group. And this carbonyl C double bond group is converted into CH3OH. So what is the way of thinking of this solve the problem? By option. So my first option, I am checking that they will provide us C double bond and CH. So by the help of the reaction of tolerance reagent, we know that tolerance is a mild oxidizing agent. So this will oxidize CH specifically, not C double bond. Tolerance reagent is also oxidize C double bond. In case of special case, only alpha hydroxyketone will oxidize by the tolerance reagent. So if I use tolerance reagent first in this compound, that means NH3 whole twice plus OH minus, this is a tolerance reagent, and tolerance reagent oxidize only, this is a mild oxidizing agent, so this is only this aldehyde group and acid group. Fine. So ketone will not hamper. Now they will provide us. So now what happens? If you introduce those two CH3 group, that means we introduce two CH3 minus, that means two nucleophile of CH3 minus. So we need help of Grignard reagent. Got understand? Then what happened? Very carefully. This CO2 OH group. Now if we have to apply two CH3 group as a Grignard reagent, so we need an eliminated group, that means a leaving group. So this acid can be written as C double bond OH group. So if we apply two CH3 group here, so we have to convert this OH to a good leaving group. By how? We have to go for esterification under an acidic condition using methanol. If we esterification will happen to this acid, then what happened? C double bond O and OCH3. Now look at very carefully. Now this OCH3 group is a good leaving group. This O is not as a good leaving group. OH minus is a good nucleophile, but it is not a good leaving group. But now OCH3 group is a very good leaving group. Fine. So we can apply 2 mole of CH3 MgBr. How? First look at carefully. If I give first CH3 MgBr, that means CH3 minus, it will look like that. This bond will open. Fine. I will write here again. This is look like OH CH3 and OCH3. Fine. So this is a good leaving group. Fine. This is a O minus, sorry. Then this O minus will back, then it will be relieved. So we get COCH3. Now further, if further I apply this CH3 MgBr, then it will become, this will become CH3 and OH under H plus, and finally if we add 1 mole of again CH3 MgBr, this CH3 MgBr attack like this one, and H, this O minus will take the H plus and converting to this product. So this is a very interesting problem. The idea of thinking, first idea of thinking that tolerance reagent can oxidize, mild oxidizing agent and oxidize specifically aldehyde to acid. Then in this position we have to apply 2 CH3 group, introduce 2 CH3 group. So we need here a good leaving group. That is why I will go for the esterification. After the esterification, we have the leaving group. Now then 2 CH3 group will introduce, and finally 1 mole CH3 MgBr is introduced to form our desired product. So this is a very important portion. So what is the option? I will take. So option C is our correct answer. This is a very important problem. This conversion, they will ask you 1 or 2 conversion like this one. They will supply the reactant product and give you 3-4 reagent and change the sequence. So sequence is first tolerance reagent, then esterification, then Grignard reagent. Okay, fine. This is our second problem. This is also came in JEE Main 2017. So now I am going to the third problem. Now my next question, the third question actually came in AIMS 2018, and this is a best problem, and this is a very tricky problem of this session. They will provide us 2 cyclic group or 2 cyclohexane group attached. That means a cyclo, this is look like a cyclooctane. Cyclo 1, I will show you the example when I write in the board. Okay, fine. So they will the system will contain a carbonyl group, C double bond group, a CHO group, and another ketonic group, and they will provide us as aldol reagent, that means OH group. So now I am trying to solve the question. So this is our third problem. Now look at very carefully. This is look like 2 6-member ring attached with each other with not a bridging bond. Okay, so this is this cyclic group containing 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So it is known as cyclodecane. This is a problem based on cyclodecane, and they will provide us OH. Very good. Look at very carefully. I am writing the reagent once again. Sorry, substrate reagent is OH minus. Draw it properly. Okay. They will provide us OH minus, that is a reagent of aldol. Actually, in this case, aldol will happen. Now, first, very carefully. In this case, there is no chance of formation any enolate because this has no alpha carbon having H. This has a chance of formation of enolate, and this has also a chance of enolate. So here, if enolate will form, then what happen? Suppose if there is a enolate form, then it is a CH2 minus, then that will attack. That will not cannot attack in this position. That is not possible because it's become fused. That is most unstable product. This can attack in this side also. Now look at very carefully. 1, 2, 3, 4, 5, 6, 7. And if this CH3 knot will attack as in carbonyl, if there is a formation of carbonyl, then that will attack 1, 2, 3, 4, 5, 6. 6 member. Fine. We know that in case of carbonyl, very important, 6 member ring formation is most stable, then 5, then 7. So if this enolate will form, this will form the 7 member ring. But if it will attack, it will form 6 member. So preference of formation of enolate is this one. Now the question is, why this will attack only this aldehyde, not ketone? We know that aldehyde is more reactive than ketone because to have the CH3 group will decrease the electrophilicity of this C-double-bond-O group. Fine. So now this will attack like this manner. Okay, now I will again not writing like that. I am now writing this is CHO. Fine. After the formation of this minus, this will occur. Okay, here COCH3 group, here the minus, and I am writing this one like this way. Okay, I will open up in above side, so this will attack this like this way. Okay, fine. So what happened? 1, 2, 3, 4, 5, 6. 6. Fine. Okay. Now this CH OH attach with this one. 1, 2, 3, 4. Look very carefully. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And this 6 member. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So by solving at least this one, we can say this option is our final product, because in this only option they will fuse like this one 6 member with 1 7 member. But I will show you the exact product. These have a hydrogen. Fine. This will go back and this weight will remove. So what happened? We have a 6 member ring containing double bond. This will go elimination by fire, E1CV. Now this will go like this one. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, and wait. This one, like this one. 1, 2, 3, 4, 5, 6, 7. This 5 group have COCH3 group. Fine. And this is attached with this one. So this is our main major product. These have lots of concept. First, the concept of that 6 member will predominantly from rather than 5 member or 7 member. Then aldehyde is less reactive ketone. That is why this enolate, this one enolate, will attack this aldehyde. And after the aldehyde, we will show you a fused formation of a fused compound. That means a 6 member with a 7 member, and here a fused ring fuse is occurred. Then this is our final product, a compound, a cyclic fused compound with a 6 member ring, has an alkene group or double bond with a 7-member ring. This is a very important problem of this is called ring closing reaction of aldehyde. This is called, and this is also called intramolecular aldol reaction. This is a very important intramolecular aldol reaction of most of favorite of JEE Main, Advanced, and mainly JEE Advanced and this AIMS type of exam. They will show you this problem very much. So this is our final product. This is, I think this is an option A. Check the option properly and note it down properly. This ring formation is a very key step. Fine. And this one, this formation of 6-member, not 7-member. Okay, this is our third problem. So this is my last problem. My last problem is based on the reactivity or order of acetophenone. Just a second. Okay, fine. My last problem is based on the nucleophilicity order. This order involves the T3 compound acetaldehyde, ketone, acetone, and acetophenone. So they will ask you the reactivity order. So the question is look like that. So first, this is my question number 4. I am writing 3 compound: CH3CHO, CH3CO, CH3, and this acetophenone. That means COCH3. 1, 2, and 3. Fine. I am open up the all compound. This is a very easy problem. This is the easiest problem of this session. Now, this is the electrophilic center. These are the electrophilic center: delta plus, delta minus, delta plus, delta minus, delta plus, delta minus. So in this case, the nucleophilicity order or electrophilicity of this carbon is maximum because there is only one plus I effect group of CH3. Then this one here 2 CH3 group produce plus 2 plus I effect. So this will more reactive than this one, and this is less reactive because it will provide you plus R effect. This will provide you plus R effect, and having plus, we know that plus R effect is more effective than plus I effect. So this plus I effect will decrease maximum electrophilicity in this aromatic group, and we can conclude. First we conclude. Look at very carefully. Aldehyde is most reactive than ketone. Previously I also said aldehyde most reactive than ketone, and between aliphatic and aromatic ketone, aliphatic and aromatic analogs in electrophilic reaction, nucleophilic reaction of carbonyl group is less. So in order is 1 greater than 2 greater than 3. This is the order. If we have the aromatic one, this is least reactive, and if there is an aldehyde, it is more reactive. So this is our final problem. Check the option, right option, and this is the order. Right order is reactivity 1 greater than 2 greater than 3. So this is our 4th problem, and this came in. Look, just a second. This is a problem of AIMS 2016. Fine. So this is our final question. So I have covered 4 different types of problem. Study very well and mainly keep practicing. I will coming further next session of PYQ of organic chemistry. So get well soon and keep practicing. Thank you.